All right, lesson 8, here we go. Get this stuff copied down. Get the pictures copied down, and then we're going to talk similarity statement in just a second here.
There's a fire right
Can you hear me?
Yes, I So close the mouth, get it written down. Let's go. So what we've got here is we've got two triangles. They look similar. We've just got to go through the process to kind of prove that they are. Now remember, for similarity, there are a couple ways that we can tell that something is similar. First of all, we have to have all three angles match up. So what we can see is angle X and angle A match up because they're both 90-degree angles. They tell us that B and Z are the same. So then we can assume that C and Y are the same also. Okay. Now, they did not tell us this, but I'm going to tell you the other way to prove this for similarity is that our side lengths have to be proportional. So I'm going to tell you that they are proportional. So then we can write a similarity statement based on that. And really all you have to do from there is you have to put triangle, and then you can put the letters in any order you want. I'm going to go ABC. And then our similarity statement, or our similarity symbol, is one kind of wavy line in there. And then we're going to put the triangle symbol. And then we've got to match up the angles here. So we had A first here. A is the same as X, so that goes first. Then we had B. B was with the one line. Well, that's Z for this other one. And then C and Y match up. So this would be the proper way of writing that similarity statement for this one. All right, any questions with that? Pretty straightforward stuff from geometry. All right, get this one copied down. All right, for this one, based on what we've done earlier this year, we should already know that these are going to end up, we've got three triangles here. These are going to end up being similar triangles. Now, just like we talked about before, you're going to have to redraw these so you know which sides and angles match up here. Okay, now remember, I put the 90-degree angle up on top. I just think it's easier that way. If you want to do it a different way, it doesn't matter to me. All right. But then we've got to figure out where the points go for our corners here. So if we're talking about the big triangle on top, we know that this is an X, this is W, and this is Y. All right, that's for the big one. For the left one then, what we do know for sure is we do know that Z is where the 90-degree angle is. From there, we know angle W is on this side. Well, it's still in the same spot for the left one. So this has got to be a W here. And that means X has to be over here. So these, the Z and the X just kind of flip. This kind of flips upside down there. All right, for our right one, we also know that Z is our 90-degree angle. What we know here is we want Y to be on the right side. Well, it already is there, so Y has to be here. And that means X is going to be on the left side. All right, and then these end up being, all three of them end up being similar triangles. So then we just have to figure out what the similarity statement would be where YZ over XY equals XY over WY. Well, we just have to find out which two triangles they're talking about here. So YZ, let's see, we've got a YZ here and an XY here, and that's the only one of the three triangles where it deals with both of these two sides. So we're talking about the right triangle here, and then XY over WY. That looks like we're talking about this one here. And notice that YZ and XY are both the right ones. And then XY is our bottom one here with our WY on the bottom here. To show that this left one is going to equal the right one, we just have to write the similarity statement for these two triangles. All right, and that's the point of drawing out those three in that orientation so we can tell what's going on here. So we would just say triangle Z, X, Y is similar to triangle X, W, Y. And then we're good to go there. Okay, this is all you would have to write for that. You just have to write what the similarity statement is. Now remember for this, like I said on the last one, for your similarity statement, your corresponding angles have to match up. So Z and X have to be the same here and all the way across. All right, if you were to write this down as ZYX is similar to XWY, that would be wrong. Okay, now do realize though that if I said triangle ZYX is similar to triangle XYW, that would be okay because our corresponding angles still match up here. All right, so you can have lots of different answers for this and they would still be correct. You just got to make sure your corresponding angles still match up. All right, any questions on similarity statements? If you have questions, you got to speak up. All right, moving on. Draw out this triangle. All right, the first thing that I see with this one that a lot of kids struggle with is when it says solve for C. If I had all sorts of numbers up here and I only had one variable here, most of you guys would get it really quick. But when they're all letters, it ends up being a little bit more confusing because of that. You still do the same steps though. All right, so we're going to kind of break this up. Now, the first thing that we have to know is we have a little triangle on top and a big triangle throughout the whole thing. All right, our main thing that we have to know, though, are these two triangles similar? What do you guys think? You got to talk. I can hear you.
Yes. Yeah.
How do you know?
Angles.
There's 4 triangles and they're all similar.
I would say there's 4 triangles.
I don't know where you're getting 4 triangles from,
But
but
similar.
we do know that our top angles are going to be the same, right?
Hey.
Do we know that this angle here is the same as this angle here?
Not technically.
Technically, we do not. What do we need to know yet?
They're
If
parallel
the
lines.
bottom.
Right. If I tell you these are parallel, now we can do this. Okay? In the book, most of the time they tell you that, so you don't have to worry about that. But I want you to get into the habit of looking for that, because if these two lines aren't parallel, you can't say anything about these two triangles here. All right? So we know those are parallel. Then we know that this triangle on top, we've got our side lengths measured out here. Okay, we know our bottom is C. How long is this left side here?
A plus B.
A plus B. That's right. And then the other one would be E plus F. All right. Now, once we know that these are similar, we can kind of do the same thing as how we showed this back here. We can set up a proportion between two similar triangles. When we know they're similar, we're going to skip the similarity statement here, and we're just going to solve for C. So what we could do, we could set up A over A plus B equals D over C. Now, that's one way to do it. You could set up this proportion lots of different ways. You could go A over D equals A plus B over C. Now, realize these two are exactly the same. The only difference is that these two are in opposite spots, right? Well, when you do the next step here, it'd be to cross multiply. You're still going to multiply these two together no matter which way you go. All right. Another way that you could set this up is you could go E over D equals E plus F over C. Now, the answer for this one is going to be very different than the answer for either one of these two. Okay, it is very important that you show me the work in this stuff so that I can walk through your steps to see whether you're right or not. Because, like I said, this answer is going to be very different than this answer. All right, but technically, if you do all the steps right, both of them are going to be correct. So the one that we're going to do, we're going to work off of this first one here. All right, and our first step here would be to cross multiply. So we've got AC equals, and you don't have to run the D through, but I'm going to right now. It kind of depends on what you want to do here, but I'm going to run it through. And then, how do we get this equation and solve for C? What's left to do here? Yep, divide by A. So C equals 80 plus BD over A. Is there anything that we can do to simplify this fraction?
No.
I mean, technically, we could pull a D out, but it's not going to cancel with anything on the bottom. So it doesn't help us at all to do that. So we can just leave it that way. All right. Yeah, for this bottom one over here, you could do the exact same thing. You'd cross multiply. EC equals DE plus DF. And then you would just divide by E here. So then our C would be this expression. All right. Technically, both of these are correct. You just have to show me the work that for whatever way you want to do it. Okay. Any questions on that? All right. Make sure you show the work. Just work through your algebra, even though it's all letters here. You're still doing the same cross multiplying and the same algebra as you go through here. Okay, so don't get freaked out because there's no numbers here. You'll be okay. All right, questions at all before we move on? Okay, next one. Tell you that those are all parallel. Go ahead and solve this one, or at least get the proportions set up. I am guessing Gavin's in there. Gavin, tell me what the proportions are going to be here.
One second.
Okay.
So would that be x minus 2 over x plus 2 equals 27 over 30?
That is one way to do it. Absolutely. Okay. Could have also wrote it as x minus 2 over 27 equals x plus 2 over 30. Both ways are going to be right. Doesn't matter which way. From there, you just cross multiply and solve. All right, so we're taking 30 times this one. And 27 times the other one. Subtract the 27 over. And add the 60 over. And then we divide by 3. So what do we get for that? 38? One of you with a calculator, check that for me. My calculator's sitting on the back desk back there. It's not helping me out much today.
Yes.
You got that? Okay. All right. Now, one thing to be aware of with these. This answer is correct, but you need to make sure that your answer makes sense in the problem. All right. So if we plug that in here, all right, we get 38 minus 2 is 36. And we get this side, 38 plus 2 is 40. Now, the picture is not accurate. It's okay, don't trust the picture. But the math has to work here. Say, for example, we did all of this work and we got an answer of x equals 1. Is there any way that x is going to equal 1 for this? What do you think?
No,
Why not?
can't have a negative distance.
Say that again?
Can't have a negative distance.
Yeah, this thing right here, if we put a 1 in there, that would be a negative 1, right? So then this answer doesn't make sense, okay? So you don't necessarily have to check your math as you're going through here, but you do have to check to make sure that your answer makes sense. We got a 36 here, we got a 40 here. Our math is good enough to keep rolling, okay? So the only thing that I would check is just to make sure that I did my math correct as I go across here, which I'm pretty sure we did. All right, questions there? All right, one more for this lesson. for this one, make sure you get this sentence written down. It's the most important sentence of this problem. And without that sentence, you cannot solve this one. All right, so what we do see here is we've got three triangles here again, right? We've got our big one, we've got our left one, and we've got our right one. Now, every other time that we've had three triangles, we were told that this was a 90-degree angle and that was a 90-degree angle. We don't know that this time. The only thing that they tell us is that this line is an angle bisector. What does an angle bisector do? Yeah, it's going to cut the angle in half. So this angle here is congruent to this angle here. Okay, now we don't really know how this technically falls apart, but due to that, we are kind of told that these two triangles are going to be similar. And then when they're similar, we can set up a proportion to be able to solve for x here. All right, and that proportion is simply the left side over the bottom equals the right side over the bottom. All right, and that's a rule that you can just trust with it. Every time that you have an angle bisector, you can set up this proportion here. So then we just cross multiply this and solve it. 18x equals 104. X equals, I have no idea. Help me out, please.
It's a decimal. It's like
5.7 repeating.
Okay, 5.7 repeating. Perfect. Okay, and that's it. Any questions there? As far as temperature goes, not too bad for that one. Good to move on to the next one. All right. While you're copying that down, get your winding outs right now.
Oh.
There you go.
Hey, got it.
Please, isn't it? Text here, man. Easier.
All right, and so this first group here, we're told that this line going straight up and down is 4. We know that this line going side to side is 4. What can you tell me about these two shapes? Yeah, they're congruent, right? Now, they're not going the same direction, but they are congruent, okay? Now, congruent does not mean equal, all right? Congruent simply means that they are geometrically equivalent. For them to be equal, they would both have to be going the same direction. All right, but because they are labeled the same, we're told that both of them are 4. That means that they are congruent. Now, the same thing down here, we can see that these two triangles are also congruent. We see that the 4 is in between angle 1 and angle 2. We see that the 3 is off the side of angle 2 on both of these, okay, which would mean that this would also be the same. When we know those two sides, well, we can figure out that this side here is also going to be equivalent to this side here. We just don't know enough to be able to say what those are. But these two triangles would also be congruent to that. All right. The same thing though, does not mean that they're equal. Doesn't have to be equal, but they are geometrically equivalent, which is what congruent means. All right, so here we go. Go ahead and write it all down. When you are doing these in your homework, the most important part that I want to see in your homework is I want to see a picture drawn of what's going on in the situation. Okay, so if they give you a picture, recopy it really quick. It doesn't have to be a great picture. You guys have seen me draw stuff. I'm terrible at drawing stuff, but you have to have a picture there to kind of be able to work off of. And then we're going to run through this step by step, and you guys know more of this than what you think you do. All right, we did talk about this, I think it was last week, that while proofs seem super annoying, they are one of the most important things that you can get out of math, because you are going to have to prove to somebody, yes, this is why this works, this is why we should do it this way, and you can show them why it's going to work. Okay, that's all a proof is. You're just going to show them this is the best way to do it. All right, so get those things written down there. Now, in every proof, there are free points that are given. Okay, that starts with right up here. Write it down first. Now, most of you remember the whole T-chart thing. All right, it's probably the easiest way to go. All right, but I would simplify things up the best I can. AD congruent to BD. How do we know that? Well, it's given to us. So there's your first step. There's your first point. Now, why did I tell you to draw this picture out? So you can mark it up as you go. Mark up AD is equivalent to BD. We know those two are the same now. All right, then DC is perpendicular to AB. All right, write that one down. Perpendicular is just an upside down T. All right, the more of the abbreviations you know, the less annoying this stuff is. So that helps out. So we've got DC is straight up and down, AB is across the bottom. So these are perpendicular. Now, what do perpendicular lines tell us? That we're going to have a 90-degree angle there, right? But we haven't done that yet. We haven't said that yet. So we have to say that in our proof. We know that angle ADC is congruent to angle BDC and are 90 degrees. How do we know that? Perpendicular lines, that's it. That's all you have to say there. Perpendicular lines. Now, we know that both of those are the same. Okay? Now, once we have that all written out, your game plan for a lot of these is to prove that one triangle is congruent to the other triangle. Now, there are different ways to prove that they are congruent. We can prove that they're congruent by knowing all three sides are the same. We can prove that side angle side, so the angle in between two sides that are right next to each other are the same. We can also prove it by angle side, and We can also prove it by what's called hypotenuse leg. And we'll talk about that one later. All right, now if you look at these two triangles here, do we know any other two parts of the two separate triangles that are the same?
The side that they share.
Yeah, the side that they share, right? So CD is congruent to CD. How do we know they're the same? Don't overthink it.
Same line.
Same side.
Yeah, they're the same line, right? Okay, now, not technically the right geometric term, but I don't care. That proves that those two are the same, okay? So now we can say that those two are the same. All right, now, do we have one of these four up here?
Just on each side.
Yeah, we know this one right here. If you look at this, we've got side, angle, side for the left one, side, angle, side for the right one. So we can say now that triangle ADC is congruent to triangle BDC by SAS. All right, and we are now one step away to getting this done. All right, now that we know that these two triangles are the same, can we prove that AC, this side here, is congruent to this side here? Yeah, we can say AC is congruent to BC. And the reason is, well, what would the reason be? What do you think? Somebody say it really loud.
Because they're congruent triangles.
Yeah, the two triangles are congruent, right? Now, there's an abbreviation for that. Okay, the abbreviation is CP, CTC. All right, sounds confusing, but you're going to use this a lot. What this stands for is corresponding parts of congruent triangles are congruent. So what we did with these first 5 steps here is we proved these two triangles are congruent. Now we can just say, all right, this piece that we need is congruent to this other piece based on the two triangles being congruent. And that's it. All right? Any questions there? Are we good to move on? Okay. Do the next one then. All right, so same thing that we started with the last one. Get that picture drawn out so we can mark it up as we go here. All right, and then let's take our 3 points. Angle E is congruent to angle H. How do we know that? That's given. All right, from there, EF is congruent to HG. We also know that to be given. All right, so that is, those are bottom two. All right, and then what we need to do here is we need to prove that this middle line here is congruent to this middle line here. All right, so my guess is that we're going to have to prove that this triangle here is congruent to this triangle here based on one of those different ways that we talked about. And remember, that was SSS, SAS, or angle, angle, side. All right, so right now, we're trying to prove that these two lines are going to be equivalent. So I would guess that SSS is going to be out. So our goal has to be then is to either find the outsides are the same, or we've got to find one of the other two angles here. Right? Oh, and there is a fourth one. I'm sorry, I forgot about it. We can also prove these by angle, side angle. So there is a fourth one there. All right, this one is a little bit harder to see. Does anybody see what we could prove here? What about if I cheated and got rid of that triangle for a second? Tell me about the triangle. No, you got to speak up. These two angles are the same. What do we know about the opposite sides? How do we know that? You're right. How do you know that these two sides are going to be the same? What kind of triangle is this? Not equilateral. We know two sides are the same. What kind of triangle is that? It's an isosceles triangle. Right? So what we can say is triangle DEF is, or DEH is an isosceles triangle. How do we know that? Because of angle E being congruent to angle H. And then once we say that this is an isosceles triangle, then we can say side DE is congruent to side DH based on that isosceles triangle. So then we can go in and say that this side is congruent to that side. Now, can we go through and prove one of these three for those two outside triangles?
Side angle side.
This is going to be a side angle side. Side angle side here. So we can say triangle DEF is congruent to triangle DHG based on side angle side. And then what's our last step? F is congruent to DG based on what?
CPCTC.
Yep, CPCTC. Right? Any questions there? This one was a harder one. All right. If I didn't take this triangle out to prove that this was an isosceles triangle, this one gets really tough. Okay, so you're gonna have to work through these. I promise you, you can get these, but you gotta work at them. All right, one more here. Lots to write down there. Go ahead and get it all written down. Get that picture out. All right, so once you get all that written down, then, like I said before, take your free points here. AG, congruent to EF. Mark that up on there. CA, congruent to CE. Let's see. Now this one's going to be harder to mark. So kind of what I like to do is maybe draw in a line showing that those two are equivalent. It's about the best we can do there. We know that B is the midpoint of CA and D is the midpoint of CE. And those are all given. All right, so what does that midpoint thing do for us? What does that tell us?
A and D are equal.
Yeah, I think I heard you right. We know that AB is going to be congruent to CB. And how? Well, that's just like a definition of a midpoint. Okay, now for your reasoning, you just have to make it make sense to me. All right, if you just said, well, midpoint means it's in the middle, so then AB and CD or CB have to be the same, I am good with that. All right, and the same thing for D. We know that CD is congruent to DE based on the same reason. All right, so gotta put 4 of them there for now. Now that we've got all of our givens pretty much taken care of now, we need to prove that this side is congruent to this side. We've only got a couple more steps to go to be able to prove that. To prove that those two sides are the same, I'm guessing we got to prove this triangle is congruent to this triangle. Does anybody see anything? Say it again.
Angle A is congruent to angle E.
How do we know that angle A and angle E are the same?
Definition of this isosceles triangle.
There you go. Yep. This is congruent to this, so we know that that triangle is congruent. So we can say angle A is congruent to angle E based on isosceles triangles. All right. Can we say that these two triangles are the same yet?
Yes.
Is this side the same as this side? I've got 4 tick marks here and only 3 here. Can I prove that this side is the same as this side? We're really close to, we would just have to say AB is congruent to CB, which is congruent to CD, which is congruent to DE. And how could I prove that? Put it in your own words. How could we prove that all 4 of those sides are the same?
Couldn't it be because the isosceles triangle all sides are the same, or the 2 are anyway? And so the midpoint means that it's right in the middle, so the sides are equal.
Yeah, the halves would have to be the same too, right? Okay. What theorem is that? I have no idea. It doesn't matter, but Hope, I assume that was you, right?
Yeah.
Yeah. What you said was 100% right. So if you just write that out here and say, all right, we know we've got an isosceles triangle where the 2 sides are cut in half. That means all 4 pieces are congruent. Okay? You don't have to give me a theorem on that. Okay? Just put it in your own words. All right? Technically, that is correct. Now, when we do that, when we say that, now we can get rid of one of these tick marks for this side. And now all 3 of those, or all 4 of those, have 3 tick marks there. So now we can prove that triangle ABG is congruent to triangle EDF. How do we know that those 2 are the same now?
Angle side.
Yeah, side angle side. And we've got 1 step to go, right? BG is congruent to DF. Based on what again? CPCTC. All right, now I'll help you out for a lot of these proofs. First of all, write down your givens. If your given means something that you have to prove, do it right away, like we did with these 2 steps here. All right? Your last 2 steps for almost all of these are you have to prove the triangles are the same. And then your last step is going to be proving the 2 sides or 2 angles are the same based on CPCTC. You just got to fill in the last couple pieces to be able to prove these last 2. Okay? I promise you guys can do these, but I do know that it takes quite a bit of work. So you have to get rolling on it. Okay? Couple things for you. first of all, homework, lesson 8 and lesson 9, any 25. All right. No quiz over these 2 lessons. All right. Reason is this will be due Wednesday. And we also have your first test on Wednesday. All right. That test will be over lessons 1 through 7, except for lesson 4. All right. Any questions for me over that? All right. Couple of expectations that I have for you guys, especially with me being gone. First of all, just because I'm gone does not mean that you can't get your questions answered. All right. I have teams open all throughout the day. All right. I was answering teams questions at 10:30 last night, right, Madison? Yeah, she contacted me last night. Okay. Do not think that, well, I don't want to bother you because you're sick. Okay. I will get your questions answered. I promise you that. That's my job. All right. So, but you got to contact me somehow. Okay. I don't care if it's Teams is probably the easiest, but if you want to go through Schoology, email, you want to text me, I don't care which way. You might just have to give me a little bit of time to get back to you, but it is your job to get your questions answered. Okay, if you don't want to talk to me, that's fine. Talk to somebody else who knows what's going on. All right, I think by now you know which kids are good kids to ask for help. All right, but you have to do that. That's part of your education that you got to get better at. Okay. The test, start studying up for it. I know it's 6 days away, but I mean, if you want to ask questions to me about certain things, you got to give me time to answer those. And like I said, I don't know when I'll be in the school next. Hopefully it'll be tomorrow, but it might not be for a while yet. So get those questions to me as quickly as you can. I would strongly suggest looking over the problems that have all the variables with all the exponents. All right. If you guys have those down, chances are you'll do really well on the test next week. Okay, because I think for the most part, you guys kind of understand it. You're going to have to know your area, your volume equations. So get those down, get those memorized. All right, but those are kind of the 2 big ones, the equations and the variables with the exponents. All right, questions for me? All right, so if Miss Savageau is okay with it, I'm good with you guys taking a mask break and go outside for a little bit, and then get back in here and get rolling on the homework, all right? Do you guys?
Hey, yo! Hey,
Hang up on it.
chill, guys.